Hey everybody, thanks for clicking on the video. In this, today we're going to be looking at how to graph a secant and cosecant graphs from the graphs of sine and cosine that we already learned how to graph. If you want to see more videos like this, don't forget to click that subscribe button. If you want to follow along, there are links to the worksheets in the description below. So for this first one, we have the graph of sine. And we want to use this to help us graph the cosecant. Now we have to remember that cosecant is the reciprocal of sine. And so what we do is we look at this graph and we say, all right, right here it's pi over 6, 1/2. What does that mean? Well, at the angle pi over 6, the sine ratio is going to be 1/2. Well, at pi over 6, what's the cosecant going to be? Well, it's going to be the reciprocal of that. And so the reciprocal of 1/2 is going to be 2. So I'm going to draw a cosecant on top of this, and I'm just going to use this as a reference point and say, well, if sine is 1/2, then cosecant of that same angle is going to be up here at 2. Now, right here at pi over 4, it's square root of 2 over 2, which is about 0.7. And if you take the reciprocal of that, that's going to be about 1.4. And so cosecant is going to be somewhere about there. And then at pi over 3, that's going to be square root of 3 over 2. And so as a decimal, that's about 0.8 or so. And so if we take the reciprocal of that, that's going to be about 1.1, 1.2, but it's going to be bigger than 1. Now at pi over 2, sine is 1. And so the reciprocal of that is still going to be 1. So cosecant and sine have the same point right here. Now at 2 pi over 3, that's the same y value as it was at pi over 3. So we're just going to take this value for cosecant and copy it over. Same thing with 3 pi over 4. That's the same as pi over 4. So I'm going to bring that right about there. And then for pi over 6 and 5 pi over 6, they're both 1/2. So 5 pi over 6 is going to be 2 for cosecant. Now what about pi? At pi, sine is 0. And so cosecant is going to be 1 over 0. And so actually 1 over 0 is undefined. And so when something is undefined, there is no value. And so often what you'll see people do is you often see a dotted line. Now I'm going to draw it in a different color because the dotted line is not part of the graph itself. It's just a reminder that there's nothing there. And to save myself some time, I can look at the graph and see where else is sine equal to 0? Well, here. And so that means cosecant is going to be undefined here. And here at 2 pi also, it's going to be undefined. There. So now, moving on to 7 pi over 6, sine is beneath the axis, negative 1/2. So the reciprocal of negative 1/2 is going to be negative 2. And so all of these values are just the opposite of what we did up here. So negative radical 2 over 2, that reciprocal is going to be about negative 1.4. Negative square root of 3 over 2, that's going to be about negative 1.1. And the reciprocal of negative 1 is itself negative 1. And so these 3 points are going to match these 3. This is the same as that, so we're going to match these 2 points. This point is the same as that, so we're going to match those 2. And then these 2 points match, so that's going to match. All right. Now, what this graph is doing is it's coming up, it's touching sine right there, and then going back down. And then over here, it's coming down and doing the same thing. Now, because sine repeats itself, so does cosecant. So that means I can fill in these points over here. So negative pi over 6, well, that's the same as 11 pi over 6. So they're going to, since they match, they're both going to have a value of negative 2. Negative pi over 4, that's the same as 7 pi over 6. So that's negative 1.4. Negative pi over 3, that's the same as 5 pi over 3. So that's about negative 1.1. And even though this point isn't highlighted, negative pi over 2, that's the same as 3 pi over 2. So we draw that down like that. And then this point right here is highlighted, and 13 pi over 6, that's the same as pi over 6. Now, even though these points aren't highlighted, I'll fill them in, because there should be a point right here for sine, and that reciprocal is about 1.4. And then this point is square root of 3 over 2, and that's going to be the reciprocal of about 1.1. And so that comes down like that. And so if you want to graph cosecant, the easiest way to look at it is to graph sine first, and then understand that when sine goes up, cosecant goes down. When sine goes down, cosecant goes up. As sine gets closer to 0, cosecant gets further away from 0, that is the x-axis. And so when sine is actually on the axis, cosecant doesn't exist at all. And so that's how reciprocals work. As one goes up, the other goes down. So this is what cosecant looks like. Now, since sine and cosine look very much the same, just moved over slightly, cosecant and secant, they're going to do the same thing. So here we've got the cosine graph. And to save ourselves some time, let's look to see where is cosine 0, because then we can mark where secant won't exist. So here at pi over 2, cosine is 0. So secant is not going to exist here. 3 pi over 2, secant is not going to exist there. Over here at 5 pi over 2, it's not going to exist here, unless I forget over here at negative pi over 2, it's also not going to exist. All right. Now, all these values are the same as what they were for sine. So here it goes from 0.5 to 0.7 to 0.8. So our values for secant are going to go from 2 to 1.4 to 1.1 to 0. And then we're going to go back up the same way. And then down here, we go from negative 2 to negative 1.4 to negative 1.1 to 1. And then negative 1.1, negative 1.4, negative 2. And then over here, this is going to mimic this over here. So it starts up at 2, because that's the reciprocal of 1/2. Then we have 1.4, that's the reciprocal of square root of 2 over 2. Then we have 1.1, that's the reciprocal of square root of 3 over 2. And then it goes back up. And so here is the graph of secant. And so like cosecant with sine, this comes down and just touches the cosine graph. And so when cosine hits its maximum, secant hits its minimum. And so when cosine hits its minimum, secant hits its maximum. Thanks for watching. If you have questions or suggestions for problems you want to see worked out, type a comment below. If you liked the video, give it a thumbs up. If you want to see more videos like this, click the playlist link to see what other videos there are for trigonometry. If you want to support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the best way to understand something is to do it.